Tell me, what are the doubts, guys?
So I've started with like the first assignment again, and I want to do the designing part. So I was watching few videos, but sir, there was many confusion in the video.
Okay. What are the confusions?
So like how to start with first of all the designing part,
Okay.
and
Can you share the screen and show me?
sir, I'm still very confused about load combinations or how to manage that.
Okay. Share the screen, I'll show you.
Yes, sir. Sharing it. Yes, sir. The screen visible, sir, to you?
Yeah, sure.
Yes, sir.
Yes.
So this was the first assignment, sir.
Hmm.
So I don't know, sir. Like when I was doing the slab thing, slab design, then and there we have to create envelope and all, and we have to design with load combinations. So I don't know what is the load combination, how to define it.
Okay. So load combinations, how to define it's very simple. Go to the define and there is an option called as load combination. So this is the option.
Okay, sir.
Now wait. Now here you can add the new particular combination or you can create it from the or add default load combination. I would suggest that to select it from here.
Okay, sir.
Now here, wait. Now as per the British code or American code and all, there are different load combinations for the steel, composite, concrete, shear wall and slab. But as per Indian code, all the combinations mostly are same. So maybe you can go for slab design or maybe shear wall design or frame design. It doesn't make any difference. So
Okay,
maybe frame design, you can select it and make sure this option is you are clicking. Because if you want to do editable certain changes,
okay,
only if you click this option, the editable option is valid. It is possible. Otherwise, it will not.
okay, sir.
Okay. So this is how it is. So once you do that, just press OK and the things are done.
Okay.
Yeah.
So this is done, so okay.
Oh, wait. Can you go back to the previous menu? Ah,
Okay.
here I would suggest very strongly that you go to individual load combination, go to the modify and give the combination which is there here. Let's say you click here, modify this.
Yes, sir.
And here you can give like 1.5 dead or
1.5,
5 dead,
1.5.
5 dead instead of dead or maybe auto sequence, for example.
Okay.
So what happens is you do not know the previous name. Am I right?
Yes, sir.
But this name actually you know what it is actually because in the auto sequence you are considering one time zero dead load only.
Mm-hmm.
All right, so this is basically dead load, but in the auto sequence load. So every floor is a different slab and all actually. So first floor, then second floor, then third floor, then fourth floor, like that actually. So it
Mm-hmm.
is like this. So it is better that to give this particular name instead of the default name.
Okay. Like
Default,
whatever the load is given, like
uh,
auto sequence is given in this case, so you have to
correct.
give 1.5 auto sequence the name.
Because here this is just by visualization you will come to
Yes, sir.
know.
Okay.
You don't need to hover your mouse.
Okay. So it's like okay.
Yeah,
And I have to do it for sir all 32 loads.
correct. And
Right.
this is one-time job only. Why one-time job?
Okay.
Tell me.
So like it's done for everywhere, then we don't have to do it again and again.
Why? How come? In the next project also you have to define the load combination. Then why I'm telling one-time job?
So for the next time when we open e-tabs, then also it's defined.
How come? What is the option?
But I don't know, sir.
Okay. So see, here you give only this 1.5 times auto sequence plus
1.5
1.5 times live load.
auto plus 1.5 life.
Oh, okay. Just say okay here. Okay. Now you have understood the concept, right? These two combinations I have
Yes, sir.
created. Right? So what do you do is you save the file.
Yes, sir.
You open another etabs from here. Imagine that you are starting with a new project, okay, and you are going to call the all the previous functions. How do you do that? Any idea?
No,
I
sir.
taught you in the basic workshop.
Uh,
Mm.
Maybe, sir, I've skipped. No, I've seen it. I don't know.
Okay, so go to the file, new, yes. Now here there are three options. So instead of default setting, you can go to the this option.
Model file. Okay.
Yes. So you are going to choose all the functions, library functions, particularly the define menu functions. You can call
Okay.
it from the previous file to the new file.
Okay. 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 So I'll okay it, sir. Then
Yeah,
that
just say
can be done.
okay. Now the software will ask you that which is that file you're
Okay. This
talking
is the
about.
file, sir. This one.
Yes, yes. So just say okay. Let's say you are doing here maybe a flat slab with perimeter or something, or maybe blank option. Maybe blank option because I think mostly you'll do the blank option, right?
Yes, sir.
Now you go to the define again.
Load combinations. Okay.
Yes.
Okay. Got it, sir.
Yes. So whatever the previous now you just no just don't just cancel it. You go to the again define.
Okay.
Now this is a new file only. Now here you go to the mass source,
Which one, sir?
mass source, mass source, mass source, mass source,
Mass source. Okay. Mass source.
mass source.
Not this.
Above the P delta.
Ah.
Uh, you go to the modify.
Mhm.
So this is also there.
Okay. Yes, sir.
Okay. So again you go to the load patterns.
Okay.
All load
Everything.
patterns are there. So
Okay. So we don't have to do it again and again.
correct. So
Okay.
particularly in the steel structure, now you go to the define again, go to the sections, section property, go to the frame section. So even the frame sections are there. So let's
Okay.
say you are having using the box section, you are using the columns like this, or you are using the column like this. So typically, let's say the railway or something, as a consultant, you are working with somebody
Mhm.
where typical sections are required. So you can, this is like a library that you can create, generate the library here, and you can call in the next file. So it's easy for you.
Okay. So I was creating this again and again.
Hmm. Okay. Okay. So what's the next question?
So next is so yes, I've done with this, sir. Now I have to start with, sir, this advanced part. So I have to first thing I have to create SMF, which I've
Hmm.
not done, sir. I have to ask only, sir, how to. What is the next step?
Yeah. Next step is you just go to the file actually and save as the file, first of all.
So
Save
for
as.
SMF, right, sir?
Uh,
No, sir,
so,
I know, sir,
so,
how to do it,
uh,
but I just want to know the steps. So next is
okay.
SMF.
So the first folder will be uncracked. Then
Okay.
the service cracked. Then
That's, sir, videos I've
uncracked.
seen, but
Yeah.
I wanted to know the steps like how to like go with
See,
it.
see, I'll tell you, Earth. Once you saw the video, no, you have to just jump.
Okay.
Okay. You don't need to again wait for somebody that, okay, I know how to do, but I don't know how to do. That should not happen.
So, sir, like, sir, SMF is done. Then, sir, like, what analysis we should do? Like, creep analysis. It was there
If
when
it
to.
is deflection governing building, now it is relative. Why we are not teaching the E-types advanced session areas into the basic workshop? It is because of that only. Otherwise, it will be like a khichdi, so many things together.
Yes, sir.
Understood. So why we are taking relatively, like if you go to the advanced areas, so once the basic like modal analysis is perfect, releases are there, You're given the stiffness, you're given the dead load, you're given the earthquake load, you're given the dynamic, static, dynamic, scale
Yes, so
factor.
these things are done, sir.
Yes, already it is done. Then you check the modal shapes because modal analysis is the behavioral understanding,
Yes,
right?
some model is sir, done, so you
Uh,
can check it,
yeah.
sir.
Okay. So once it is done, then you go to the next one,
Advanced.
which is advanced part. Yes. So for that, you have to save as the file, create a separate folder. Okay. And first is serviceability. Give the serviceability check, SMF actually. I try to give the SMF here only. And today only I have discussed with one of the offline student here. He has done the mistake that, initially he has given that application because from here also you can assign it as an applicant, like let's say 0.7 for column or maybe 0.35 for the beams, 0.25 for the slabs. So he has done the application. Later on he has forgotten at one particular place, so he was thinking that it was already given in the definition dialog box, so it was neither given here and nor given to the application. So I
Okay.
would suggest that not to give this option. You have to create in this particular option
This one
only.
only, yes, sir.
And you give that assignment number one new, like let's say uncracked, then give service
Uncracked.
service cracked,
Service crack, strength crack.
strength cracked, so you know that which file you are working on. Because each file there are three models. Certain things, uncracked model, you are checking the modal analysis. Service crack model, you are checking the drift deflection. Then you are going for the, let's say, the strength design, let's say vibration analysis or buckling analysis, torsion irregularity. You are going to do the strength model.
Strength. And so designing also we have to do in strength only.
Correct, of course. So there is no confusion for that.
Okay.
Understood. That's
Okay.
how it should be. Correct.
And so I wanted to know the videos, like this is the videos one.
Mm-hmm.
Like for sir, this designing part, like what are the videos exactly, sir, where to find it?
No. Don't jump. You have to go for basic. See, you are not given the serviceability checks also, right?
No, sir.
Why?
So I've
What?
learned it. I've done in this other assignment,
Okay.
and I've learned about creep also, gust factor, and everything. I want
Okay.
to learn about designing, sir.
Ha. Then designing, actually, you can go with the advanced workshop videos initially
So
over
this
here. Yeah. You can go through one by one, actually, all the videos. And then
okay.
you can go to the session videos of E-Tabs Advance.
Okay. Session videos.
Hmm. In the session videos, actually, there is shear wall designing,
Yes, sir.
all these things will come. So one by one, actually, you can, because there are so many, designing is not like that straightforward. Okay. Sometimes you have to use the Procon, sometimes you have to use the spreadsheets. So relatively, you need to start studying. So that's why initially, first is what you need to do is ETABS basics.
Yes, sir.
Once that is over, basic.
Advanced.
Then you go to the advanced. Then you go to the session videos. Session videos, actually, because there are so many session videos are there. So let's say this is earthquake engineering. These are design parameters, actually. So what are the parameters are there? And it is not just the parameters. It is along with the design we are showing. So this is what it is done. Then come back to this. Then again go back to this. So like that it is. So each video is almost like 1 to 1.5 hours, right? So
Yes.
like that, it will take some time for you to go through all these videos and all, actually. And design is relative. None of the video is 100% perfect. Sometimes some particular thing will be good at this particular area. Sometimes something would be good at this because, the shear wall design. For example, I'll tell you shear wall designing. Where it is? Yeah, shear wall designing. Shear wall designing also, there is a object-based modeling. There is a shear-based modeling. There is a flexure-based. That is what the peer labeling. So based on the type of the element, we need to change this particular pattern. So in one of the video only, everything cannot be covered. Understood? Yeah. Hello. Hello. Am I audible? Jose,
Hello.
Chandresh?
Hello.
Hello. Am I
Hello.
audible?
Yes,
Yeah.
sir. Hello.
Sorry, I think I got disconnected in between.
Yes.
But that's what actually, what I'm saying is in only one video, everything cannot be covered.
Okay,
That's
sir.
how, we have created small sessions of all the videos and all actually. And then you start. But I'll tell you, it is comparatively quite simpler. Once you get used to it. Initially, you might feel it is little difficult, but later on you will see that no, this is perfect.
And sir, one thing more about the creep analysis, sir.
Hmm.
Like when
Yeah,
to apply.
yeah. Before going to that, actually, I would like to just go back to this particular option. Go to this option. Yes. And here, yes, ETAB's core videos are also given. Go up
Yes, sir.
slightly. Basic, advanced, and yes, ETAB's core videos. So these also you can see that. You see, this is shear wall design, frame structure. Now, these are basically overrides and designs. These are some core level session videos. So it has basics and advanced. Once the advanced part is over, there is no particular scheme that you can fly anywhere because you know how to fly basically. Now you need to design the pattern that how do you want to learn, because some people will wanting to learn steel structure, some people wanting to learn the RCC structure first. So depending upon the parameters you can decide. Yeah, one more thing is, now there would be certain confusion about related to this. So we have created one Excel sheet.
Yes, sir, I've seen that, sir.
Yeah, can you open it now, please?
Excel sheet, sir. A minute.
I think some PDF or Excel sheet is there. Catalog, yeah, I think this one, right?
Yes, sir.
Yeah, just open it. Yes, now this is what it is. So depend, see, this is the date. Okay, based on the date, you will see that geometrical complexity. This is a timeline of each and every video. And who has done that video? What is basically the number of minutes? Okay, so let's say I know the geometrical complex. I don't want to waste time here. Peer labeling also. I know this. I know this. I know this. I know. Let's say then you can go. This is G+42. I know. I want to learn this. Then open this video. Understood. So this is how actually you can start learning basically. Now this is 3D DXF import. I do not know this. You go to only this particular timeline. So why 600 to 700 hours of video? And 6 to 700 hours actually, I think 2 months back I have calculated. And now it has gone to up to 800 hours. I'm little reluctant in adding the videos. Why? Because too much of videos also gets, sometimes confusion to some people. Understood. But some say it is very clumsy and complex actually. So line area, line element idealization. So this is very important topic in the advanced areas and all. So go through that actually and just go to down a little bit. All the videos everywhere actually, all the videos we are given. Session wise, small. Let's say stiffness and time period change. SMF. Go down. Go down. Yes. So 107 minutes, 85 minutes, 106 minutes, 36 minutes. Shear wall idealization. There's that. Types of dampers. Okay. So this is the advanced areas. You go down, the auto sequence, creep analysis. So which particular topic you are interested into? This is only the definition of, end of this detailing topic and all.
Yes, sir.
Yeah. So let's say wind cladding. Actually, I wanted to study this wind related things actually. So you just go through that. It's related to basics. So I know this. So don't waste time here if you already know it. Understood?
Yes, sir.
Yeah. So see, tactfully you need to do this course. See, 2 years of MTech, we need to finish within 5, 6 months. So obviously we need to do something different. Am I right or wrong? Yes. Yes. थोड़ा होगा, I mean, गड़बड़ होगा, कुछ, some issues would be there with you guys and all actually. But yes, eventually you'll get used to it. Just keep patience, keep watching videos, keep doing practice like this. Very good job here. So how many projects you have done, Arth?
So I've done so 5 as of now, the
Very
basics
good.
and bit of
Okay.
advance.
Okay. So 5 projects done in how many months?
So 2 months, maybe 3 months.
2 months.
Three.
Fantastic. Correct. So if you go to the BTech or MTech, actually, within 2 years, they will finish one project. That too, 50%,
Yes, sir.
90% copied, right? So within 2 months, you have
Now,
finished
sir, in
five
these
projects.
5 projects only, I want to, like, before going forward, I want to do this advance and maybe designing also.
Yes, yes, that is what I wanted you to understand. See, some people would like to take, okay, I have done only 2, 3 projects, but I wanted to take it till the end.
Yes, sir.
Some people will say that now I wanted to study basic first, then I'll go to the advanced first, then I'll go to the safe first. So individual it is. I don't want to put my, learning habits on yours.
Got it, sir.
Got it? So this is how I wanted to keep that thing open. That's why after, let's say, 2, 3 months, 4 months, actually, it is little bit more disorganized. But I wanted to put it disorganized, because if you go to any company also, yeah,
Mm-hmm.
Earth, yeah, but give me these foundations. Earth, have you checked the stability? Please give me the report, DBR of this. Anything will be there, and there is no organized way of handling the client also.
Got it.
Okay, so in that disorganized environment, how are you organized in adjusting yourself and motivating yourself to give the proper delivery of the output? So that is what you need to learn after 3, 4 months, basically. This is the real important core of learning.
Okay, sir.
Sometimes some people feel a little bit more clumsy and, oh my God, what is happening? So for them, we tell them, pack your bags and come here. There is no other way. Okay. But some people, they pick it up, actually. I mean, this is how it is, actually.
Yes, sir.
Yeah. So,
So one question I had regarding creep
yeah.
analysis, sir.
Yes.
It's like I've learned about creep analysis in the video and applied it also.
Mm,
But sir, when to do this, like it's not happening in every project.
mm.
So when to do this, and because I've studied also, it says like when it should be edge by 350 or 20 whichever is critical or whichever is less, then we should do it. But sir, I don't get that.
Yeah, if it is deflection governing building, or sometimes it would be, transfer girder, or, such kind of projects, you
Sir,
definitely
how
will
to
have to do.
identify this is deflection governing?
Edge bed to the, 350 or 20 the values will be coming very close to the permissible limits.
Sir, how to like go to that value?
Then run the analysis. I'll show
Okay.
you right away. Now here also you have added auto sequence. Is it needed? Not needed. Okay. Just because you know certain things, just don't add it. Okay. It's not good. If it is really needed, then add it.
Okay, sir.
It will take a little bit more time for running the analysis. You are a doctor of the building. कोई भी patient आता है तो ये same injection, don't push the same in dose. Don't do that. Okay,
So
try
P
to see
delta,
that
so
P
P delta,
delta. Yeah, P delta might be required. Auto sequence may not be.
so that is the thing, that is the very
So
confusion.
no, auto sequence, I told you now which particular project. If you see that our videos also, I have told you. So let's say a particular project actually. If you are having, let's say, the transfer girder like this. Now this particular column is not going down.
Okay, okay.
So this particular, you will have the huge amount of deflection at this particular places. So you have to do the auto sequence case. Okay, instead of the dead load, you have to go to the auto sequence. Because initially this is the building. On the top of that, you are adding the load.
Yes, sir.
Now this load is all the entire load of this particular column, which is sitting on this frame initially. Because from this beam, you are going to take the dowel bars outside. There is no building on the top, because construction analysis is from the top to bottom. Construction is from bottom to top. The
Correct.
sequence is different. Let's say, for example, this is a building actually. You are not actually manufacturing the building and bring it and what is the analysis, show me. No, it's not happening that way.
Yes,
But
sir.
you are modeling in that way, which is insane. So you need to model it the way that it is getting constructed, floor
Constructed.
by floor, brick by brick.
Yeah.
That's why such type of analysis is required. You are basically mimicking the same parameters and same sequence, how the way that it is happening. Yes, we are taking floor by floor, but in reality it is you can divide it like half this side, half that side also. Sequence analysis is quite powerful tool in Midas Gen software, Midas SDS, and also the ETABS and SAP 2000. So these four softwares, auto sequence analysis, script analysis, is very powerful. Okay, now we will check the deflection. Just go to the 3D view. Okay, how much is the deflection value? Let's say maximum deflection value. These are the maximum values, right? This is blue color maximum values. So how much is the deflection? Maybe here. How much is the value? 2 mm, 2.5 mm. How much is the span? Now you go to the undeformed shape now. Go to the floor. Go to the OHT. Okay. Now you see this particular span from here to here. How much is this? Uh, 1.1780, correct?
Yes, sir.
Divided by how much? 350. How much it is?
Okay. 1780 divided by 350. So 5.
5 mm. So allowable deflection is how much? 5 mm. Now this is basically you need to see the axial shortening also. So means you go to the deflection again. How much was the deflection at the tip? Just say okay. How much is the deflection at the tip?
So 2 point something.
2 point?
So here it's showing 4.
I think then we have taken the wrong value. Yes.
4.9.
Okay, so 4.9 mm, correct? Now, how
Yes,
much
sir.
is the deflection at the column point? Yes, minus
3.3.
3.352. How much is this?
So,
Let's say 1.7 approximately, or
yes,
6.
sir. 4.9 minus 3.
1.548.
1.54.
Okay,
1.6.
1.6 will take roughly. Into creep coefficient is how much?
3, sir.
3. Okay. 4.8 mm allowed. How much
4.8.
how much is the deflection value that you are getting?
So 5 point something.
No,
5.
no, no, no. This is what it is you are getting, because this is the actual deflection at the tip here. This is the actual shortening at this. This is the resultant deflection. See here, this is the deflection, correct?
Yes, sir.
So this is the deflection. But in the reality, this is not something it is happening. What is happening is this is also getting deflected. It is going like this. So what you need to do is, this is, let's say, delta 2, and this is delta 1. So delta 2 minus delta 1 multiplied by creep coefficient, correct?
Yes, sir.
That is, we are considering it as around 3. So delta 2 is how much? 4.9. 4.9 minus 3.352 multiplied by this, which is
4.8.
4.8. So this is the actual deflection is coming here. How much is it is allowed? 1780, no? 1780 is the length, correct? This
Yes, sir.
length.
Length. Okay, huh?
1 minute, I'll just. So 1780 divided by 350. How much it is?
5.09.
5.09. So which is more than this value.
Yes,
Hence,
sir.
okay. No worries. So no need creep.
Okay.
And even if you need it at only this age. So what you do is you tell the person actually that this is OHT, right?
Yes, sir.
Floor is OHT and LMR. So you tell them that at this cantilever, I do not want this load.
We can
You
shift it to
shift
the other
this.
side.
So there is no problem only in this building. Then why to invite?
Right, sir.
Uh, so don't do that actually. So see what will happen, Arthur. There is no problem in doing the creep analysis
Just
also
like a
to the
time
building.
wasting thing.
Time wasting, no, because it will take another 4 5 minutes every time for running the analysis and all,
Right.
and ultimately you are not getting, because creep analysis you are not going to use it for designing. It is only for the analysis and stability checks, right? That's how it is.
Okay, so what this point, sir?
Yeah. Anything else?
No, and sir, just like my house was getting constructed, sir.
Wow.
So,
Okay.
so next month we are planning this architecture plan to be final after 10 15 days. So I was thinking, sir,
Okay.
if like I can only start with the structure thing or maybe design with just G+2
Okay.
only.
Okay.
So is
Okay.
it possible? That's why I wanted to ask.
Generally, we don't recommend that actually.
Okay.
You appoint a consultant, you
Yes, sir.
be there, no problem. Okay.
Okay.
Now imagine that you are not a dentist.
I know, sir. That's what
So,
I'm
so
thinking.
don't try on your own
No, I'm not
Danikal.
trying, sir. I'm with the help of sir, the team,
Uh-huh.
your team. Like if
Then it would be, see, because the entire consultancy is different.
okay,
Okay, definitely, you can be a part of this and all, actually, will help you out. But
okay,
majorly, you appoint a consultant and then learn that how it is done, why it is done. Sometimes it is, it is given for the benefit for the laborers or workers on the site. It is not needed here. Nowhere it is required. Okay, but it is easy for them because every rebar actually they have to chip and all, actually it will take a lot of time and it is uneconomical also. So you would learn quite faster first because it is your own house first.
yes, sir.
Second thing is actually, you are seeing the model, everything. You are also looking at the construction. So you use that opportunity to learn much more faster. Okay. Hello? Hello. Sorry, I think some issue is there with my net.
Yes,
Okay, understood, Arth?
yes,
Yeah.
sir. Done.
Okay, okay.
Yeah.
Anything else? Anybody? Arth, do you have any other doubt apart from
No,
this?
no, sir. No, sir. I'll start with
Okay,
the
yes.
video.
Okay, okay. Joyce?
Hello, sir. Sir, good
Yes,
evening.
hi.
Stop the screen.
Yes, good evening.
Sir.
Yes.
Sir, I had a doubt regarding the pile foundations.
Okay, okay. Can you share the screen quickly?
Yes, sir. Yes. Okay. I placed this is for the flat slab project. I'll just show you the pile layout that
Sure,
I've
sure.
drawn.
Yeah,
Okay.
yeah.
This is how I have given. Okay,
Okay.
I'll show you with the shear walls. 1 second. Okay, this is how it is with the shear walls. This
Mm-hmm.
extra line is coming when it is overlapped, but
Mm-hmm.
okay. This is how it is.
Mm-hmm. Okay.
Here it will be changed. It will be this is not correct. It will be a hexagonal shape here, but this will
Okay.
be
No, no, no. If it is a hexagonal shape,
okay.
so you need to consider that is it 2.5 times the diameter of the bar? I mean the pile.
Yes, it is.
Let's say you are having, sorry, I'll use the another color pen. So let's say there is one more hexagon here, and there is one more hexagon here. So whatever the distance between these two piles,
Mhm.
how much is the distance?
It will be more than that. 1 second, sir.
What
yeah,
should be
this
the
is the
maximum distance?
this is the okay, this file and this file, it has like 5,000.
Okay.
The pile dia that I have given is since I didn't know how much is the capacity to be taken for the pile, I randomly took it, some values like
No, no, no,
5,000.
don't do that actually. See, you can open the Procon and you can start designing and get it done from that. All right.
But I was not. Can you show that, sir?
Open the Procon.
Okay.
I'll show you. Yeah, go to the geotechnical.
Sorry. Actually, it was.
Yeah, this. Go to the geotechnical. Go to the pile.
So the maximum distance between the piles is there a constraint? Like the minimum should be 2.5 to 3 times the diameter. Is there a maximum distance between the?
See, 2.5 times or to 3 meters. Like that, the distance actually. 2.5 times is practically, theoretically, it is 3 times.
Okay.
Okay.
Okay,
Now,
so
yeah, now, wait a minute. See, first of all, I would like to tell you that, you know, what is the type of the material? That is very important. Then what would be the basically the SBC of the soil in those areas? These values are also comparatively quite important. Okay. So if you are having lesser values, for example, this is basically the major value, which gives you, because there are two types of strengths are there. One is basically the resistance. 1 minute. Abhishek. Abhishek. Sir, darwaza nahi. One is end bearing and another one is skin friction. Correct?
yes.
So you're having this skin friction here. Okay. Like let's say this is the pile. Okay. It is going down. So one is like you're doing like this. There is a skin friction. One is end bearing. There is a rock below. So there is end bearing below this. This is end bearing. And there is a skin friction here.
Okay.
So what happens is majorly contribution will be there. Maximum of the end bearing bit depends upon this. So if you are feeling the I may not get this much actually the capacity, maybe you can reduce maybe half of this or maybe quarter of this and all actually. Who will tell you this? Geotechnical report. So many people actually itne ka pile hai, 500 ka pile hai, so this is the capacity. 600 pile, this is the capacity. So I don't believe on that actually. I believe on the scientific method actually. What is the length of the pile? What is the diameter of the pile? What is the underground strata and all actually. I have seen that 900 pile also they are giving lesser capacity of the 600 pile because of the kind of solid strata underneath actually. That is what actually this calculation is all about. That's why I asked you to open this particular software. So what is this? This is the SBC, level SBC. Up to 2 meter, this is the soft rock, very dense sand, sorry. Then there is a soft clay, up to 6 meter. Then there is a very soft rock, which is capacity of 200. And this is the capacity of 400. So are you getting this capacity of 7.5 meter below the capacity of 400? You can just call the geotechnical consultant, ask if these values are correct, then these values are correct. Go to the analyze. Then these values are correct. So you are getting how much actually? Total capacity, allowable capacity, you are getting this. Screen friction, end bearing, total is this. So you are getting this much capacity. So what is the total mean? This is the at the first layer. First layer is this layer. This is second layer. This is second layer. So if you are cutting the pile here, then this much capacity only you will get. Understood?
Okay.
So this is that particular value. So depending upon that, actually, that's why actually you need to go to the geotechnical report to see that. And currently, if you do not have something, actually, yes, 7.5 meter easily you'll get 200 kPa. No doubt about it. So you can blindly use these particular values in general way. Huh?
Okay.
So
Sir,
you can
this is for
900. So you reduce the diameter in that case. Give 600.
Okay, if I give it 600.
Go back to this. See, the capacity is reduced.
Okay. All right. So this is how, sir, actually for a column, for that flat slab project, it was like 42,000 kilonewton was the column base shear.
No. Base shear is not needed actually.
No,
What we
not base
require is
shear, the base reaction, the base reaction, sir. Sorry.
at one particular column.
Yes.
Are you sure?
Yes, sir. It was 42,000. I'll show you.
Yeah, it's a high-rise building actually, commercial.
It was G plus 16.
Okay. So 42,000, then you need to increase. See, maximum actually you can go up to 1.1 meter. I have gone up to 1.2 meter also in Dubai. That's the diameter of the pile.
Okay.
See, the criteria is increase the diameter of the pile and reduce the number of piles. Instead of 1, 2, 3, 4, 5, 6, instead of 6 piles, if you can work with one, let's say 1, 2, 3, 4, 1, 2, 3, 4, but bigger ones.
Okay.
It is good.
All right.
Because the contractor's rate will be based on how many, kitna number of piles hai, how many number of piles are there. Depending upon that, the rates are considered.
Okay. Sir, and also this arrangement of pile for the shear wall here, is
So
this?
that's what actually, it is good arrangement, but even though actually, I would like to avoid this instead of 1, 2, 3, 4, 5, 6.
Okay.
Try to give 4 piles. Try to give lesser numbers, higher diameter. You can go up to 1.2 meter. This is Mumbai. See, 1.2 is okay. I'm very much optimistic. You can at least go up to 1 meter, easily possible.
Okay.
So in the 1 meter, you might require maybe 3 piles. 1, 2, 3. Matter is over. Instead of so many piles, because see, I'll tell you. Can you go back to the previous this this sheet?
The same
Procon.
Okay.
Yeah. See, imagine that you are having one more, pile here, one more pile here, for example. So in that case, what happens, the pressure, actually, pressure bulb over here, it gets connected like this. So this much area resistance would be reduced drastically. So it will reduce the skin friction. Also, it might reduce to certain extent the end bearing. So if you increase the number of piles like this, it is going to reduce drastically the group capacity. It is not multiplied by this 3810 multiplied by, let's say, 3. It will never happen.
Okay.
The group capacity. Although we take it that way, but it doesn't happen that way.
But that is the reason why we are giving that 2.5 diameter, right?
So that is there, but still in the 2.5 diameter, see, this is 7.5 meter down, right?
Yes.
So pressure bulb will go like this.
Okay.
Yes, the overlap will be minimalistic. Lesser overlap will be there, but it will be there to a
So
certain
it is
extent.
better to go for 3 times dia.
No, not. It is better to go for lesser number of piles with higher diameter.
Okay, okay. All right, sir. And sir, one more thing for this. Is this advisable? This
That is okay.
this is
See,
this
all
is
the
the shear
piles
wall.
need to be, all the piles need to be underneath the shear wall, or all the piles need to be away from the shear wall. Both are okay.
Okay.
But here also I would suggest instead of 4 piles, if you can go for maybe 2 piles or something would be better.
all right. Okay.
1, 2, like this.
Okay.
Yeah, like this, correct.
Okay. So even if this was a single pile, would it have been okay? Or because it is a shear wall, is there something like minimum of 2 piles is required?
Minimum of 2 piles. Why it is required? Tell me.
Because it might have a
See,
overloading.
there is a force and there is a bending. So whenever there is a bending, this is a pile, this is one pile. So whenever there is a bending, this is under compression, this is under tension. If there is single pile, how are you going to transfer the bending action of the column? Because you are considering the fixed connection in the E-tabs. The moment you are considering the fixed connection means the vertical force as well as bending in this direction, in the other direction, plus the forces, all these things will not be managed by a single pile, not possible only.
Okay.
So the moment you are giving 2 piles, what happens is axial force will be distributed by half here, and the bending action will be distributed as a part of the tension and compression here.
Okay.
That's why minimum 2 piles are needed.
Okay. Sir, and can you just check my this is the Anteri project
Yeah.
draft.
Okay.
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 This is the continuous rebars that I required was T20 at 100 in X direction and T25 at 100 in the Y direction. And these are the additional steel. It's like 32 dia. It comes at certain locations here.
So again, yeah, we need to see the safe model actually, and then
Okay.
do this. Yeah.
Okay.
See, one more thing I would suggest. Yeah, it's good that you asked me. This is T20 at 100, which is very, I don't like 100 number. I'm sorry to say that. Minimum 125.
So that
100
means the
number is,
diameter can be increased.
see, instead of that, actually, this is like throughout you are giving, right?
Yes, yes.
So instead of, let's say, like this, maybe here you can increase the bar diameter in certain places, or maybe a little extent more. I see. Let's say T20 at 100. Instead of that, you go for T25 at maybe 150 or maybe something like that.
Okay.
Because see, 100 is clumsy. I mean, see, one rebar, two rebar, again, you will have so many rebars together.
Yes.
So let's say this is, this is the raft footing. There is another layer of raft footing. Plus, you'll have the rebar from here, rebar from here. So huge amount of these things are going like this actually. So that's why I'm asking. For example, I'll just show you. Hold on. Just to give me a moment. Can you stop sharing the screen if you don't
Yes,
mind?
sir.
Yeah. I'll share my screen. Can you see the raft casting which is happening?
Yes, sir.
See here. Now, can you realize?
Okay, okay,
Hmm. That's why every Saturday is site visit day.
okay.
Oh, look at this.
Mhm. Okay,
This is raft, bottom rebar. Top. This is top rebar.
okay.
See here, bottom rebar. So it is really difficult actually. You will have rebar here. This is 150. So if you are having 100, it is quite nearby. Plus there is rebar here. Plus there are two layers. So see this is 2.3 meter depth. So the concreting has to go from top to the bottom, right?
Yes, yes,
There is a top layer also is going to come here.
yes,
This is just the bottom layer. Top layer is, can you see this rebar which is going like this? Because
yes,
top
yes.
rebar is at this level.
Okay,
So
okay.
how are you going to monitor the concreting has happened below the bottommost layer?
Mhm. Yes, yes.
So these are practical problems which, that is difficult to understand. So I'd like to show you a few other photos. See here. Yeah, this raft is constructed. This is basically the Surat project of Tower B. See, this is done. So, yeah, this is concreting. See here. Now these people are sitting on the top. Standing on the top layer.
Yes.
Understood. So what happens in such kind of cases, no, it is very difficult situation uh, for this person to check that at the bottommost, because this is almost this raft is at least 1.325 something like that, but here it is 2.3 meter. So in such kind of cases, not possible only to deal with all this actually.
Mhm.
But try to increase. This is 150 spacing. So this is 150 is considered to be ideal spacing.
Okay. Okay. So while calculating the crack width, I should be taking it into consideration.
Ah, yes, yes,
Yes.
yes.
Okay. Okay. So,
Yes. Anything else, Jos?
Hello, sir.
sir, regarding, and there was one more thing regarding the flat
Yeah,
slab.
Chandresh, I'll come back to you. Okay, wait here after
Uh,
Joyce. Yeah.
a very small doubt, sir.
Yes.
Regarding the flat slab project, the thickness of the slab was 30 centimeters and the drop was 70 centimeters. It is very huge. This was for the creep criteria that I had to increase it so as to reduce the deflection to about 20
No,
millimeters.
no, show me, show me. Seeing is believing.
Okay, sir. This is a flat slab strength model.
Yeah, you have not shared the screen.
Okay.
Yeah. Chandresh, what is it regarding actually? Which project? I think your sound is not coming properly. Please check it out. Just another few minutes. Don't worry, I'm not
Mas
going till I finish all the doubts. Okay, don't worry.
okay, sir. Mysore project.
Mysore project. Okay. See, this is a flat slab project and high-rise building. Means what happens is there is a drop panel here, there is a flat slab here and all. Okay, so in that case, you need to do the creep analysis, of course, because the deflection governing structure, because there are no beams here, right? Yes. See, don't go to the 3D because 3D will take a lot of time. This is also you need to sense that which particular floor, how we need to do. Take a typical floor
Okay.
and then go to the this option, which is the perspective toggle view.
Okay.
And then you go to the this view to rotate it. Just click it here. And then rotate it. Instead of 3D, this is quite better to maneuver and all actually. Otherwise, laptops, desktops.
Okay, so only
not
that
simple.
floor is visible now.
Correct.
Okay.
Now, yeah. Now you go to the deflection and show me. Hello, good evening, Manikandan. How are you? Yes, so this is the deflection.
Yes, sir.
Now, you're checking the deflection for which particular load case, which is creep, and
Yes.
which is 41. Okay,
Yeah, that is a 50 years.
50 years. Okay.
Yes.
Okay. Can you please show me that define and all actually?
Okay.
Let me check the creep parameters given properly or not.
Okay.
Go to the load cases. Go to no, not here. Load cases. Go to the creep. Go to the modify. Okay, so go to the stages, operation stages. Okay, so base 0, ground 21. 21 days is the span. Okay, go to the next. 21, first floor all, first floor all. Okay, second floor, third floor. Go next. Fast, come on. 7, 8, 9, 10, 11. Okay, terrace. Wait. Now this is OHT. Fine. Go
Yes.
next. Now all, then less than 3, greater than 3, 0.5, 0.5, 0.25, 0.25 taking. Okay, fine. Go to the next. Okay, this is 50 years. Now
Yes, sir.
next.
That's all.
That's okay. Directly you put the 50 years.
Yes,
Okay,
sir.
anyway, that's fine. Okay, fine. Just go okay here. You're given time dependent. Very good. P delta. Okay. Good. I think all is good here. Now
Okay.
just show me the define parameters of the creep.
Material properties.
Yeah. M35 you're given
Yes,
everywhere,
sir. Yes,
or
yes.
in some places M25 also.
No. Just M30.
Okay. Okay. So creep is given, and these are the parameters based on the CBFI code. Fine. Okay. Now you show me the deflection.
Okay. So the maximum is 53.944.
Yeah. No. Here you show me. Don't show there.
It is 1 second, sir. And
No, because here it will show you the worst in the entire building.
yes.
I don't want that.
But that will give the
No, but
actual.
then you need to see that where it is coming. Then only will identify the problem.
Yes, sir. Okay.
Again, go to the
Okay.
toggle.
This is where I'm getting it.
Okay, very good. Okay,
0.701.
53.701. Okay. And what is the actual shortening?
Uh,
Very near to the column. Which is the nearest column?
this is the
Okay,
this is
nearest column. Okay,
a
so how much it is?
portion of the shear wall. Okay, this is 33.187.
Okay, so one is
187.
187. And this one over here also there is some column.
But that wouldn't be. This is the nearest location. I
Okay.
had checked with
Okay, so minus 33 point, how much it is coming? So let's say 20, 20.7
yes, sir. 20
approximate.
point, yeah, 6 something would come.
Okay,
But
20.6.
yeah,
So
so
what is the span?
the span is like 15 meters by.
So it is slightly more than 20 mm.
Yes, yes.
So see, this much no, with the reinforcement, it can take care. Don't worry.
Okay.
Okay. Yeah.
So this is like 13,
13.3, no? So
13.3. Yes.
13,375 divided by, let's say,
Yeah.
350. How much?
This is 11.1. The
Ah,
shorter
so
span is
shorter span, 11,
yes.
1, like, divided by 350. How much?
It's
Ah.
31.7.
So this is governing. So 20 mm, yeah, don't worry. It is
Okay.
hardly 0.6 mm you are struggling.
Okay.
This will be easily taken. Generally, we are not adding any reinforcement detail, right, in the slab. That
Mhm.
will be definitely take care. You can easily ignore this. Don't worry.
Okay. So, and one more thing, if see this structure is very heavy with the flat slab being 30 centimeters and the drops are 70 centimeters. So wouldn't be the better option would be giving post tension slabs instead of
Yeah, one more thing is actually some people will say why 0.6 mm also should not be disturbed. So let's say I'll give you the answer in brief.
okay.
You go to the, let's say, E-tabs.
Okay.
What is the total dead load, lie load you have considered?
The
You are,
entire
yeah, you have considered 0.25 times the live load. Okay, sustained
yes.
live load. That also will not happen. Sustained live load for the period of 50 years.
Mhm.
Correct?
Yes.
That is never going to happen. Correct? 50 years you are having furniture, same amount of load, same amount of furniture at one place only. That is not going to happen. Correct?
Yes. Yes.
Another thing is you go to the, how much is, you go to the undeformed shape initially. And right click this particular, this, and yeah, go to the loads. How much is the load? 2 and 4.
Yes.
So why 2 also?
That was the dead load. The
See,
superimposed dead load due
you
to
can
the
easily reduce to 1.25 to 1.5 easily.
okay.
Okay, if you're providing the Gangsa granite also, it will never come in the range of 1.75, 1.5 or 1.6 or something like that is enough.
Okay.
2 will never come. So that's the reason this 0.6 mm will never come. It will be even reduced than that.
Okay. And regarding that 4 kilonewton per meter square,
This is
that
a,
should be
this
taken.
is a commercial, right?
Okay.
But 4 kilonewton per meter square you're taking on the terrace, which is highly unlikely.
No, this is not. Okay.
This is terrace. Come on.
Yes, it was wrong.
Yes, this is wrong. Okay. Anyway, you have understood the main.
Yes, sir.
Where are the mistakes, right?
Yes.
Yeah. Okay.
Sir, and regarding this doubt I had, was it actually constructed with this so much heavy slabs, or was it converted to?
I'll just check with my previous database. I'll come back with
Okay.
whatever the actual things that we have given. But
Okay.
it is closer to what you have. What is the thickness of the slab that you are given?
The slab is 30 centimeters, 30.
300. And our drop panel?
Drop is 70 centimeters.
Okay, 700.
And
I think the drop is little less. I'm not sure. I have to check my previous records.
okay, okay.
Okay.
But when I told somebody that I designed such a a flat slab, then that person was asking me, why did you go for such post tension these things were available, but how come you didn't? I said I didn't know how to do the post tensioning, and my scope was to design this slab. And then he was just saying, that might have been too much heavy.
Yes, yes.
Yeah.
See, post tensions, actually, I'll tell you. I mean, even I'll be prone to the post tension, particularly here. Okay. The only problem is the capabilities and the calibrities of the post tensioning people. If the post tensioning consultants are giving certain issues, they are not tying these particular things here, actually, The entire deflection, everything will be on stake. So we
Oh.
generally ask this risk to the client, do you want to take it? If they're saying, yes, we want to take it, go ahead with the PT. If they
Mhm.
don't want to take it, then go for RC. RC is a long-term perfect solution. PT is, short-term, 10, 15 saal, 20 saal, 25 saal, like that. But after that, the post-tensioning, are you going to give the guarantee 100% for the next 50 years that post-tensioning rod will be like this only? Come on, be surreal. Not possible, right? Yes.
Yeah.
Mm,
Okay.
mm.
And how is this
It's
pre-camera?
questionable. I mean, I'm not saying 100% possible or not possible. It is questionable. It is debatable. So
Okay.
I don't want to debate on something because I wanted to make sure that this building stands at least minimum 50 years. That's why the ROI will come back. Otherwise, it will not come back. Right? 16-story building, right?
Sir, was it even possible to reduce the thickness of the slab and then give a
Yeah,
pre-cam?
easily. Pre-cambering and all also can be done. And the thickness, I'm telling you, that the drop panels also can be 600. And this also like RCC slab also instead of 300, you can go up to 275. 300 also is okay. We are given 300 slab thickness for flat slab many places.
Okay.
Yeah. If it is Dubai project, I would definitely go for a PT because I know that, the people, the clauses, the laws over there,
Mhm.
absolutely fine. But here in India, if PT is doing some kind of shabby mistakes, you will be answerable also. And that to prove with the Indian court system is, oh my God.
Okay.
Okay. So all these reasons are there actually. Yeah.
Okay,
But
sir.
yes, you are right. PT, I would definitely, if the PT consultant, PT contractor is perfect, obviously I'll jump on it. I'll watch for that. Okay, but extremely long-term deflections and all actually hyperstatic analysis, many things actually need to be done for this.
For the PT slabs?
Mm.
Okay. Okay. Thank you,
Okay,
sir.
yeah, welcome. Yes, any other question, Jos?
Sir.
No, sir. Thank you.
Okay. Yes,
Hello, sir.
Chandresh. Yeah, hi,
Yes, sir.
hi.
Sir,
Yes,
can I
Chandresh.
share my screen?
Yeah, of course.
In the buckling analysis, I
Okay.
just follow all these steps. But I don't know, sir, how to check that this template is safe in buckling or not, sir. How I know that?
Okay, you're doing buckling analysis and this is slender building, so obviously buckling analysis is required. It's good that you're done. Now, what's the question?
How I know that the this building is safe in buckling?
Okay, how do you
I
know that?
follow all these steps.
Okay, so just go to the define. Please go to the define dialog box and show the buckling load case. Go to the load case. Go to the buckling modes. Modify this. Okay, so you are giving, okay, this is scale factor is 0.871.
Yes, sir.
That's all, huh?
Yes, sir.
So buckling is not governing then.
Sir, then how I know that the buckling is governing or not, sir?
That's what the scale factor will tell you, no?
Okay, sir.
Mm.
This scale factor
So
is
just say cancel this. Cancel this. Go to the bending moment. Bending moment. And in the combination, go to the buckling mode. Correct. Just apply. Okay. Yes, and check only the columns. It is not governing till here. But I think
Yes.
here it is slightly governing. Can you go check the how much is the bending moment? Just zoom in this area. How much it is? Values are less,
Yeah. Yes, sir.
quite less. Check the beam. Beam, it will not come. Yes, I think you can ignore. If the values are substantial, you should take. If the values are like this, then I don't think it is needed. Check M22, M11, axial forces, everything. Yes. So how does it impact if the 0.01 kilonewton, 0.07 kilonewton is increased or decreased? Okay.
Yes, sir.
Mm. So this is how it is. Torsion.
Is there any permissible limit for buckling,
No,
sir?
not permissible actually. You should know that how is it really worth doing this analysis. It's good that you have done it in template model so that it is basically you are trying to understand the fundamentals of buckling analysis. Am I right?
Yes, sir.
And this is what you learned, correct?
Yes, sir.
And this is how you have to check whether it is okay, worth giving, right? It's
Yes.
there everywhere. It looks quite big. Oh my God, oh my God, oh my God. But how much it is? 0.7. Okay, that's it. Anything else apart from this?
Yes, sir.
But it's good, Chandresh, that proactively you have started working on it. Fantastic.
Thanks.
Okay.
Sir, in this project, sir,
Yeah.
in model analysis,
Okay.
you Z value is coming out, sir,
16,
0.1698,
so 17%,
16%. Yes, sir.
16.9%. So I mean, ideally it should reduce lesser than 5% actually. Just check if it is
Yes.
possible.
I just
Yeah, you tried, you are
gender
not tried enough.
orientation.
Yeah. Just say done here. Go back to, yes, you have to try quite a lot. See, it will take me hardly some 5 minutes to tell you this, but I want you to try. Okay, you try enough.
Okay.
I'd like to give you one clue. Okay, clue is actually the moment the building will start rotating. The moment if you want to arrest this rotation, actually you can give some kind of corner this thing, or maybe over here also it is okay.
Shear walls.
The L-shaped walls or something, it would help you.
Okay.
This will arrest in the rotation. Rotation will not happen.
Okay.
Okay. Based on this clue, you start working. It's very easy for me to guide you in this, but I would suggest that you invent what to do.
Okay.
Okay. Anything else, Chandresh? But
Yes,
it's
sir.
good pickup.
I
You
am,
really picked up well.
sir, I'm little bit confused in auto sequence envelope and also in how to, sir, how to know that the deflection is coming out is
Mhm. So deflection, how to check the deflection? That's the clause, right?
yes,
Okay. Deflect, what is the clause actually? Span by 350
sir, 3
or
yes,
20 mm,
20 m.
whichever is critical. I think if you remember, just few minutes back, we have done it with Earth, correct?
Yes,
How to calculate and all. The same way
yes,
we need to calculate. What is the span actually? You'll take what is the span here? How much is the span divided by 20 mm? How much it is allowed here? And how much it is coming here based on the
Yes.
dead load and some percentage of live load on this. And yes, we will deduct the axial shortening and we'll multiply with the creep coefficient multiplied by 3. If it is really coming closer to this, actually, you do the creep analysis and check. These columns are
Okay.
quite bigger,
Sir,
Chandresh.
yes.
I will not be allowing. Quite bigger. Come on. You don't need
Okay,
such
sir,
a
I
big
will
column on the
reduce the
terrace.
dimension.
Yes, on the terrace floor,
Okay,
you
sir.
need such a big column. Come on.
No, sir.
Huh? See, I think you are working on the uncracked
Stem is
model. You
also,
go
sir,
to
very
the
weak.
service crack, strength crack, and all actually slowly. Okay, and then you take a call on
Yes,
this.
sir.
Currently, I'm sure that you are working on the model analysis and other, but since you are gone for the buckling analysis, which is the ETABS advanced part and all, actually, I'm sure that over the period of time you'll see that how you can give the economized location or the sizes of the columns. I think the locations of the columns are okay, but I would suggest that the sizes of the columns are pretty high specifically on the how many story it is?
Sir, 14
14 story,
on
right?
basement.
So
Yes.
this is too high. What is the size of the column? This is too high. I'm sorry to say, on the terrace floor particularly. It will eat up the entire carpet area, which is not admissible by any of the client. Okay.
Sir, how I know that the column size is good for this long span?
And how can you give
Is
508? Why, what is 508?
I just applied. I just applied.
How can you measure 8 mm on the side? Come on, be real.
Uh,
Ah,
by using converter of inches in amounts, that's why
be
it is
real. Be
508.
real. No. Give 300 by 750, 350 by 750, something like 400 by 750.
Okay.
It's also okay. 500 by 750 is also
508 is 20 inches,
no,
sir. That's why.
no.
Okay, sir.
You optimize the
Sir, is
sizes and later on we'll see the deflection rather because the behavior, the column sizes changes, behavior will change quite a lot.
okay, sir.
And be real, actually. This is not realistic figures. The beam size is also
Yes, sir.
horribly, nobody will accept this beam
Very
sizes.
early.
Why 230 by 305? Come on. If it is a secondary beam, this is the beam, for example. I'll give 150 by 300. Why 230? Minimum size is this, right? Not correct.
Yes, sir.
Sizing of the beam, please work on it. It's not right.
Sir, how I know that the sizing of it, about
See,
sizing
this
of
is the
it?
experience, right? You're doing this. Okay. So you do this. This is the first project. I think maybe third project. You do this for another 2, 3, 4 projects and all, you will get it. Secondary beams, let's say this is secondary beam, Chandresh. Okay. Why you need 230 at the first? This beam is okay because it is, it is a frame structure. It is a properly frame structure.
Yes, sir.
Now, why this is going actually? I don't know. 1 minute. Huh? Properly frame structure. So whenever the horizontal forces are applied, then obviously you would require, the framing structures properly.
Yes.
The beam sizes properly. But if it is a small beam like this, you don't need it. If it is small beam, small beam, small beam, small beam, this beam also I'll give, let's say 150 by maybe 350 or 400. It's not connected to the mainframe, but yes, this is needed. This is needed. This is not needed. This is not needed. No need, no need, no need. Need. Needed. Much more needed, this one. Because there's a main frame. Sorry. This is the main frame, correct?
Yes, sir.
So try to give the sizes and this kind of things properly. Got it?
Sir, is position of column is right or
I think position is okay. I don't think there is an issue. Every other thing looks perfect. I have loading and all. Actually, you can ask. You can check it one more time. Because just now I have seen the Joyce has given incorrect loading. So loading, releases and all, actually don't do the mistakes there. But overall other things are, it looks perfect. Okay.
okay, sir?
Anything else, Chandresh?
No,
Yes,
sir.
releases are also perfect. So go step by step. Give the vertical forces, gravity forces, releases, support conditions, diaphragms. Check one by one all the parameters based on the workshop which we have given it to you. Now the sizing of the beams and columns is incorrect. So similarly, what is the size of the slab here?
230.
230.
Sorry, sir, 200.
Okay. And then where is this
So,
230? 250.
sorry, yes, sir.
Have you designed this slab initially?
No, sir. Design.
Then you design that particular slab first in the Procon or in Excel, or you use some add-on tools. Okay, because this will change the sizes of the columns also, no? Beam
Yes.
sizes, column sizes, all will change depending upon the thicknesses of the slab that you are guys are. Now
Sir,
ST, the
these
stair.
four.
Now see the staircase slab actually over here. This is staircase slab. The staircase is
Yes.
one way only, so this is the big span. So in the staircase you might require maybe 200. This might be a little less, but at some places you are given 250 or something.
Yes, sir.
Just check if it is too. I think 200 would be enough, I guess here. Just check it up.
It was showing high deflection, sir. That's why.
Yeah,
Almost
okay.
250.
250 are given. But have you checked the creep and other things actually?
Yes, sir.
Check it one more, because the increasing the slab thicknesses, no, it will increase the quite a lot of load on slab beam column putting.
Yes, sir.
Okay. Anything
Okay,
else?
No, sir.
Okay. Yes, Manikandan.
Yes, sir. Good evening, sir. Can I share
Yes.
my screen?
Yeah.
Yes, sir. Hello, sir. It is visible.
Yes, visible.
So in that initially it is model is proper, sir. But after the and first initially I got 1.5 second as a time period first mode.
Okay.
But now it is getting something higher value. We don't know, sir. So this is what the this much time period is getting.
Can you show me the deflection shape? Don't go to the UZ. Go to the resultant. Yes.
Yes.
Go to 3D. Close this. 3D.
Yes, sir.
Time period is coming how much you said?
That is 400, sir. Initially it is 1.5.
Go to the undeformed shape. And press this button.
Yes, sir.
Can you rotate slightly up or down? Show me the properties.
This is
I think some issue has happened. We need to investigate this. 400 seconds. Okay, show me
yeah.
the modal shape. I think that is better to check. Modal deflection. No. now अब आ गया ऊंट पहाड़ के नीचे. See what is happening. I'll tell you. Certain slabs are modeled as membrane, and
Okay.
you have discretized those slabs. Means given the meshing,
Yeah.
just close it.
Yes, sir.
Go to the undeformed shape. Go to the properties,
Yes, sir.
slab sections, membrane slab. Just right click it, select, select, select. No, not modify.
Okay.
Select. Selected.
Yes, sir.
Then go to the assign. And first is basically unlock the model. Okay. Then go to the assign. Go to the shell. And this is meshing. Auto floor mesh options. And here, no meshing. Click here, no meshing. Okay. Now run the analysis. Still there is issue. Cancel this. Done. Um, Go to the membrane. I think just check the modify this now. Okay, cancel this. I think it is meshing issue only. But 200 seconds. Okay. I hope you have not changed the properties and all actually of the material properties. Can you just check the material properties?
Yes, sir.
200 thick means the somewhere you have given extremely low stiffness someplace. That exactly we need to investigate. Where exactly? You send us the model, we need to check it.
Okay, sir.
You send it to Abhishek,
Okay, sir.
okay, and the teams, and or you send it to me directly. I'll just check it up.
Yes, sir. Okay.
All right. Okay.
Okay.
Anything else?
So one more thing, if the zone is true also, if the height of the building is more than 15 meter means, whether we are going with the dynamic analysis.
It is better to go for dynamic analysis. Okay.
Okay, sir.
G plus 1, G plus 2 you can avoid, but G plus 5, 6 story buildings and all actually it is preferred.
Yes, sir.
Code is also saying. See, if you are having
Yes, sir.
confusion, it is always preferred because dynamic analysis is considered to be more realistic than the static one. All right, so it is always preferred.
Yes, sir.
Yeah, the question is whether to go for static or not. In the if there is a transfer girder or something, you should not be going for static analysis, even if it is G plus 2 or G plus 1. Okay, so that's how it is.
Yes, sir. Yes.
Okay, anything else?
Thank you, sir.
Thank you.
No, sir.
All right, so thank you so much, Chandresh
Thank you,
and
sir.
Manikandan. Okay, and we'll see you in the upcoming sessions. Thank you so much. Bye bye.